And welcome to our mixture percent problems lesson. Our learning target is that you can write and use algebraic expressions and equations to solve percent word problems related to mixtures. We have two examples today, so let's go over them. Okay, in our first example, we have a 5-gallon container of trail mix is 20% nuts. Another trail mix is added to it, resulting in a 12-gallon container of trail mix that is 40% nuts. All right, so the question we want to know is what percent of nuts is the second container? Okay, and that's what we want to try to answer here. So what percent did we add to that? Okay, when we're adding a problem like this, we have two parts equaling a total amount. So we're going to have our first part. So our first container, our first batch of trail mix, plus our second batch of trail mix is going to equal our total amount. Okay, so we're going to write an equation that kind of fits this with the information that we know. I'm going to set this based on the fact that I know what the 5-gallon is, so I'm going to use that as kind of my template for my working with. So I know that that's 5-gallon is 20%, so I'm going to do 5 times my 0.2 for 20%. Now I'm going to add it to my second batch. My second batch, I do not know my percentage, okay, that's going to be X, but I do know how much is in there. It's 12 total minus the 5 from the first one, which means I know that that's going to be 7. Then my total amount is going to be my 12-gallon times my 40%, which is going to be 0.4. Okay, now I'm just going to do the work and solve this. So first I'm going to do simplified terms, so it's going to be 1 plus, that's going to be 7x equals, and 12 times 0.4 is 4.8. Subtract 1 from both sides, you get 7x equals 3.8. Divide both sides by 7, and I get x equals 0.5429. Okay, now I want to know what percent of nuts is in the other trail mix. So I'm going to multiply this by 100, and that's going to give me about 54%. So I have about 54% of the second trail mix is nuts. That's how we're going to get that answer. Okay, let's move on to example 2. In example 2, we're working with clay. So we have soil that contains 30% clay is added to soil that contains 70% clay to create 10 gallons of soil containing 50% clay. How much of each soils is combined? So in this one I know the percentages, but I don't know the soils. So again, I'm going to take the first soil plus the second soil, and that's going to equal my total amount. So my first soil, that's going to be 30%, so I'm going to do 0.3 times x, I don't know how much, okay, plus my second soil is going to be 0.7, and I'm going to multiply that. Well, I can't use x because that represents the first soil, and I don't want to use another variable, so I'm going to have to relate it to my first variable. I know that there's a total of 10, so my second soil is going to be 10 minus however much I use, x, for my first soil. Okay, and then that's going to equal my total, which is going to be this 10 times 50%, or 0.5. Now I can solve this equation, so it's going to be 0.3x plus plus 7 minus 0.7x equals 5. Combine my like terms, I have 0.3x minus 0.7x, so it's going to be negative 0.4x plus 7 equals 5. Subtract 7 from both sides, so I get 0.4x equals negative 2. Divide both sides by negative 0.4x. Sorry, negative 0.4. And that's going to give me x equals 5. So I know that x is 5. X was the first soil that I used. So I know that the first soil, okay, the 30% soil is 5 gallons. And then to find the second soil, I'm just going to do 10 minus 5, which equals 5 gallons. So I put the equal amount of each soil in there. So I have 5 gallons of the 30% soil and 5 gallons of the 70% soil. Okay, so that's how we're going to do those. And those are basically going to be the formula that we're going to be using for these problems today. Okay, and if you need to watch anything, again, go ahead. Otherwise, have a great night.